members of the committee. I very much appreciate allowing myself to speak on really the supply chains that are going into these to make these lithium-ion batteries. My name's Simon Moores. I'm Managing Director of Benchmark Mineral Intelligence, and we spend most of our time further up from where the battery cells are actually produced. We go from the battery cell plants to the mines and everywhere in between to track data, price data, market data, numbers on the industry, what's happening in the real world. And I wanted to outline the state of play in the lithium-ion battery industry, which is obviously extremely relevant for energy storage as the applications you mentioned, which would be stationary utility storage, and then also, most importantly, electric vehicles. And so, from our perspective, we're in the midst of a lithium-ion battery arms race around the world. Over the last 3 years, we've seen these lithium-ion battery mega factories, which are battery plants above 1 gigawatt hour capacity, rise everywhere. It started with the Tesla Gigafactory in Nevada, but now we have 17 of them worldwide, and they continue to be popping up everywhere. The key thing is not just the size of growth that we're about to see in the lithium-ion battery industry. We expect that to go from 80 gigawatt hours in 2016 to between 550 and 650 gigawatt hours demand by 2025. But it's the impact this is having on the raw material supply chains. So these are the critical raw materials that go into these battery cells: lithium, graphite, cobalt, and nickel. And it's important to understand these raw materials not as commodities, as we would probably be familiar in understanding minerals and metals, but specialities. These are niche industries. These are tailored chemicals and materials that go into batteries, and the industries have to go from the niche to the mainstream. So the production of these raw materials and these intermediate products have to become an order of magnitude bigger over a very short period of time, between 5 and 7 years, in order to meet the demands from the auto companies and from the energy storage facilities as well. This means money, quite frankly. For example, we've seen lithium price increase 4 times in the last 2 years just because there isn't enough supply to meet demand driven by the battery sector. So in this recent price spike, lithium has raised about $1 billion, but really between $7 and $10 billion are going to be needed to fuel this energy storage revolution, to actually get the batteries into production, into the market. So that's a complete change in how these mineral industries operate. Where we stand today, China is not only at the center of mass market electric vehicles, but it is at the center of all of these supply chains. It's not just where the resources lie, but it's actually the key steps, the battery grade processing steps along that supply chain that really we have to be focusing on. China controls the development and deployment of these electric vehicles, but cathode production, battery grade production, and building out of new cells capacity. So of the mega factories mentioned, 64% of that capacity is being built in China. Only 13% so far is being built in the US. This could change over time as new plants get planned. So we're at the beginning of this energy storage revolution, which I think everybody really agrees with now. This is powered by lithium-ion batteries initially. The energy storage space, or the utility storage space, should I say, will have many opportunities for other batteries, such as vanadium flow as well. So there are many risks and many opportunities, and we're just starting. But I'm happy to answer any questions you have and very much appreciate your time.
Thank you, Mr. Morris. Appreciate the focus on the critical minerals, just the beginning of the discussion here when we're talking about what will be needed to help facilitate the storage. Mr. Seifforth, welcome.
Chairman